Welcome to Module 1, Lesson 27, Solving Percent Problems. So after today's lesson, I would like you to be able to find the percent of a quantity and solve problems involving finding the whole when given a part and the percent. So now we're taking it a step further again and looking at percent problems in terms of word problems and really looking at the word of. We know of tells us to multiply, and then the order of the words and what they relate to and represent and how we can put those together to answer questions. So we really have to remember that part to whole ratio and how it turns into a part to whole value, so that way it helps us when we are multiplying and trying to put pieces together. All right, so to start off, we have example 1, where we're going to solve the following 3 problems, and we're going to write the words percent, whole, or part under each problem to show which piece we were solving for. So in this case, we have 60% of 300. So if I want 60% of 300, I know 60% means 60, that's my part, out of 100. But now here, I want 60% of 300. So I want this much out of this many. So usually we work out 100 out of 100, but now we want to work out of 300. So I know that if I were to draw grids, I could do a grid where I have 60 out of 100 colored in here. And then I would do another grid where I have another 60 out of 100 colored in, because what that means is that's another 100, and I'm going for 300. And the reason that I know that that is my whole is because I'm looking at 60% of 300, of telling me that this is my whole group and I want 60% of it. So this would have to be my whole, and I'm looking for what is that part equal to. I know the percent and I want to know what that percent is equal to as a part. So in this, so this is 60 out of 100. And this is 60 out of 100. Again, these are just rough drawings, but I did go just a little bit of a ways over half. And I'll go again. Now, the reason I did 3 blocks of 100 is because I'm looking for 300. Now, this is nice and simple because 300 is a multiple of 100. So I know that if I have 300 pieces and I want 60 out of every 100, which is what we said that percent means, that means that I want 60, 120, 180. So my part should be equal to 180. Now, the other way that I can look at this is saying, okay, well, the value is 60 per 100, but I want to know how much it is per 300. And we know all about equivalent ratios. We could do this in our sleep at this point. And I know that to get from 100 to 300, I had to multiply by 3. So if I'm multiplying my whole group by 3, then I need to multiply my part by 3. 60 times 3, well, 6 times 3 is 18, plus 1 0, it's 180. So here's my visual again. If it's 60 out of 100 and I want that out of 300, that means I have 3 sets of 100. 60, and I'm taking 60 from each, so I'm taking 180. So 60% of the whole group of 300 would equal a part of 180. 60% of something is 300. Well, now this is a little different. So I know 60% of something, so I know the percentage. So 60% of something is 300. Well, that something is going to be my whole number because the of is always connected to my whole number. So of whole number, that order is always going to be the same. And then my part in this case is 300. So now, again, I know that 60%, I can write it as a ratio of 60 per 100, which then turns in a value of 60 over 100. And I know 60% of something, so in this case, I know that it's always part over whole. In this case, I know my part, so I know that this has to get to 300. I have 300 parts, but I want to know if I have a part that's equal to 300, then what is my whole group equal to? Well, I know to go from 60 to 300, I multiply by 5. And I can check that easily by ignoring this 0 and ignoring this 0. Okay, if I ignore 1 here, I can ignore 1 over here. 60 times 5 gives me 30, or 6 times 5 gives me 30, so 60 times 5 should give me 300 because those extra zeros are already included in my numbers. What I do to the part, I have to do to the whole. So if I'm taking 5 times as many parts, then I need to have 5 times as many wholes. So in this case, 300 is 60% of 500. So it's a little bit different because in this case we were looking for the denominator and here we were looking for the numerator. So when we were looking for our part, we were looking for the numerator, which we know that's always where the part goes. And when we were looking for the whole, we were looking for the denominator, which is always where the part goes. Well, now I have 60 out of 300 is what percent? Well, obviously we're looking for the percent. It shows us right here. And I know that since I have 60 out of 300, this doesn't say 60%, it just says 60. So 60 would be my part out of my total or my whole of 300. So in this case, I have a part of 60 out of a whole of 300. Now, so my ratio is 60 per 300. And I want to know what is that equivalent to if I do a percent per 100. So something per 100 so I can turn it into percent. So in this case, and I'm actually going to erase this and rewrite it, and I'd like you to write it the same way I do, so you might have to erase, I apologize. Because we've been working with the percent on top and writing it first, so having something over 100 is equal to having the part, which is 60 in this case, because it's 60 out of 300. So out of, again, of is connected to that whole, which is 300, so we know that goes on the bottom. And I know 60 is a part because 1, it doesn't have the percent sign attached to it, and 2, it's saying 60 out of 300. It's like saying if we had a class of 28, saying that we have 4 out of 28 students missing. That's a part out of the whole. Now I'm just working in reverse, so I know that in order to go from 300 to 100, I actually divide by 3. So in order to go from 60 to my percent, I have to divide by 3. 60 divided by 3 is 20. So 60 per 300 is equivalent to 20 per 100, which we know means 20%. Now here, we're looking for yet another piece. This time we were looking for that numerator over the 100 though. So we were looking for the percent because the percent always, always, always goes over 100 because percent means per 100. So you'll notice for the part, I was looking at the numerator of the part-whole ratio. For this one, for the whole, I was looking for the denominator in the part-whole ratio. And for the percent, I was looking for the numerator in the part per 100 ratio. So making sure we know where those pieces, again, looking for that word of. Whatever of is connected to is that whole group. So if I say 50 out of 100, 100 being my whole group, 50 being my part, and I'd be looking for my percent. If I say 30% of 400, that means that's how much I have. So think of it in terms of like groups of people. I want 4 out of 5 people. Well, that means you have 5 and you want 4. So the whole is 5 and the part is 4. Really focusing on reading these out loud is what's really going to help us get through this and put the pieces in the right place. Even as an adult, I still do that, like even going to the store and figuring out percentages off and such. Making sure to put the numbers in the right place is super important. All right, so now we're on to exercise 1. And in exercise 1, we're going to use models like the 10 by 10 grid, ratio tables, tape diagrams, double number line, whatever we want to use. And we're going to solve the following situations. So Priya is doing her back to school shopping, and we're going to calculate all of the missing values in the table below, rounding to the nearest penny, and calculate the total amount Priya will spend on her outfit after she received the indicated discounts. So what I'm actually going to do here is I'm going to do one with you, one, and you're going to check back, and then you're going to do the last three on your own. So here I'm looking at an original price of $44. Again, original price. So if it's the original price, this is our whole, and amount of discount would be our part. So in this case, the shirt was 25% discounted, so it's 25% off. So if I'm taking 25% off, okay, and let's do, I know we really have liked the tape diagrams lately, so let's kind of stick with that. And it's 100%, of course. 100% now would be equal to 44 because that's the whole price. And I want a 25% discount. So to do that, we're going to break up the 100% into 4 groups because I know 100 divided by 4 is 25, and I want to get to that 25%. I also know that I can divide 44 by 4, so that should allow me to find my correct numbers. So 44 divided by 4 I know is 11. So each box is worth 11. 11, 22, 33, and then of course 100% should be $44. So if it's at a 25% discount, that means that the shirt is $11 off. $11 off. Now that doesn't mean that it's $11 total, it means that it's $11 off. So what this tells me is, and we might want to add a little box down here, and we could say for sale price. So now the sale price would be that 44 minus 11, so that shirt is going to cost Priya $33. All right, so now what I want you to do is I want you to take a look at this and I want you to try it on your own, but know that this time they gave you the amount of the discount. So they didn't give you the whole this time, they gave you the discount, which we said is the part. So I want you to use one of your models, whichever one you feel most comfortable with, and when you come back, we'll check your answer. All right, so for this next problem, we have our diagram. So we have 0 and 0. Now in this case, we know that we have 100%. But we don't know what the 100% is. This is what we're looking for, which is odd for us. This is a kind of new way of looking at it. And we know that it's a 30% discount. So when we break up 100%, we have to get to 30. So the best way to do that, we're just going to go by tens. So we have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so then it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So now I know that if I'm at 30%, that it's $15. Now this is where it gets hard because we're in the middle here. We're looking at this going, wait a minute, how do I find all these other pieces here? This is weird. Well, I know that 30% it gets me to 15. So what I can look at is I have 1, 2, 3 boxes right here that when I add them all together, it gets me to 15. Well, I know that 15 divided by those 3 boxes is equal to 5. So I took the 15 and I divided it by the 3 boxes and I got 5. So I know each box is worth 5. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So I know that the original price of the pants was $50. Again, I found that because since 30% was equal to 15, and I had those 3 boxes that had a total 15. So this, this box plus this box plus this box had to equal our 15. So I know that my 5 plus 5 more plus 5 more would give me 15, telling me that each box had to be worth 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, so then now the reason I need that original price is because I want to know how much, again, this is the discount. This isn't how much she paid for the pants. This is the percentage off. This is what we have to subtract from the original. So I'm taking 50 and I'm subtracting 15. So I borrow and I get 5. 4 up here. 4 minus 1 is 3. So she paid $35 for the pants. She didn't pay 15, she paid 35. 15 was the discount. I can't stress that enough. You have to make sure that you're subtracting the discount. All right, so now you have the shoes, her necklace, and her sweater left. Again, make sure you're looking for the right pieces. Okay. When all is said and done, I will tell you that you should get a total cost of $165. So her total should be $165. Now, your work should match it, and you want to make sure that it does. And of course, if you try it and it doesn't, I do want you to go back and take a look at it and see if you can find your mistake. If not, we can talk about it in class, write down questions, circle pieces where you think you might have gotten something incorrect, and just try. Be prepared for class. That way we can really go over this and help you out and have you working on it and understanding this as best as we can by the end of class. Again, make sure to write down any questions and circle any problems that you had, but please make sure that you try.